3 Atlas has all kinds of surprises. We've only seen a handful of blurry shots that look like a tail is kind of starting to form. There's the unusual chemical signatures. It's producing way more nickel than iron, and scientists don't really know why. And when it comes to size, some estimates say it's about 3 miles wide. In comparison, Manhattan, it's only about 2 miles wide, and that is at its widest point. Interstellar Object 32 Atlas reached its closest approach to Mars on October 3rd, passing less than 2 astronomical units from the red planet. This moment marks a critical period for observation as several probes surrounding Mars have the opportunity to capture images and data of this rare interstellar visitor. However, this opportunity coincides with an unusual event on Earth, a United States government shutdown. The shutdown has suspended many NASA operations, leaving websites and social media channels inactive and depriving the public of official updates at a time when attention to the skies is most crucial. The timing is coincidental but has raised eyebrows within the scientific community as access to data about this unique event is limited by administrative paralysis. 3 Atlas has drawn significant attention due to its anomalous properties traveling at about 60 kilometers per second and projected to reach up to 68 kilometers per second near its perihelion on October 29th and 30th. It moves faster than most known comets or asteroids. Its trajectory is unusually well aligned with the ecliptic plane of the solar system, and this alignment has sparked speculation about its origin. Some have even suggested that the object may not be entirely natural. While most researchers remain cautious, its peculiar features such as its high velocity, the absence of a typical cometary tail, and its unusual brightness profile have deepened the intrigue. At the moment of its closest approach, Earth-based observations of 3 Atlas have become extremely difficult. The object's current position places it near the Sun from Earth's perspective, meaning the glare renders it nearly invisible to ground-based telescopes. This configuration, known as a superior conjunction, effectively hides 3 Atlas from Earth's instruments. Recent imagery from late September and early October, taken before the object disappeared into solar glare, represent the last Earth-based views until it reemerges later in its orbit. For now, Mars and its orbiting spacecraft provide the best possible vantage point. Fortunately, other space agencies beyond NASA are active. The European Space Agency has scheduled extensive observations of 3I Atlas during this critical window. Meanwhile, several Mars-based platforms, including the Perseverance rover and multiple orbiters, may already have recorded useful imagery. A notable example has already surfaced from Perseverance itself. On October 2nd, an observer analyzing the rover's sky images noticed a distinct streak across a sequence of frames. Over 9 minutes of data, the images revealed a bright object moving rapidly across the Martian sky. When examined closely, it did not match the expected motion of stars caused by Mars's rotation. Its path and apparent velocity were consistent with predictions for 3I Atlas's trajectory. The appearance across multiple consecutive frames ruled out the possibility of a camera artifact, indicating the rover had likely captured the interstellar object as it passed by. Analysis of these images provides limited but valuable data. The observed elongation in the exposures matches the object's direction of travel, reinforcing that the streak represents genuine movement rather than imaging noise. This sequence also demonstrates that 3 Atlas is extremely fast-moving relative to Mars's background stars. The estimated minimum diameter of the object based on brightness and distance models currently centers around 5 kilometers, though some analysts suggest it may be larger. Many amateur astronomers have managed to image 3 Atlas with modest equipment, suggesting a relatively high intrinsic brightness and possibly a large reflective surface area. Although the Perseverance imagery is low resolution, it supports the overall assessment that 3 Atlas is a significant and unusually bright interstellar object. Because NASA's public data servers are currently affected by the shutdown, updates have been inconsistent. Researchers and enthusiasts are manually checking FTP servers and alternative data channels to locate new imagery and telemetry. Given the current administrative freeze, many expect delays of several days or longer before official releases become available. The European Space Agency and other national space programs remain operational, and their upcoming data will likely be crucial for continued observation. 3 Atlas has already been the subject of multiple observations in the past weeks, including a series of significant images taken between September 25th and October 2nd. The earliest in this recent series, captured by astronomers Gerald Raymond and Michael Yerger from Namibia on September 25th, depicts the object before it encountered a coronal mass ejection CME emitted by the Sun. In that image, 3 Atlas displays a bright green hue and an unusual anti-tail and sunward-pointing extension of gas and dust rather than the long solar opposing tail seen in typical comets. Its structure and coloration indicate the presence of ionized gases interacting with solar radiation in atypical ways. Just days later, 3 Atlas was struck by that CME, raising expectations that its structure might change. Yet, subsequent images, including those taken on September 27th by Mr. Roman, show little difference in appearance. The object's shape and brightness remain steady, suggesting a surprising resilience. The lack of a visible change supports the view that 3 Atlas does not behave like a normal comet. Most comets subjected to such an energetic solar event would exhibit fragmentation or increased outgassing. Instead, 3 Atlas remained largely unchanged. By early October, Roman's latest imagery still showed the same rounded coma and diffuse structure, albeit with slightly more ionized glow, likely due to continued solar heating. The observations collectively indicate that 3 Atlas possesses a large stable coma, an envelope of dust, gas, and plasma surrounding its central nucleus. Infrared imaging and other analyses estimate this coma to extend nearly 700,000 kilometers in diameter, roughly half that of the Sun. This immense size, combined with the lack of a typical tail, challenges simple classification. Its ionization and symmetry are unlike those of other comets currently active in the inner solar system, such as A6 Lemon or R2 Swan, both of which exhibit well-defined elongated tails. Instead, 3 Atlas appears as a luminous sphere of diffuse material glowing evenly and displaying structural layers with varying densities. Polarization data suggests that its outer and inner regions scatter light differently, revealing complex compositional differences within its surrounding envelope. This behavior complicates efforts to categorize 3 Atlas. While mainstream institutions like the European Space Agency continue to describe it as a comet, some independent researchers classify it more broadly as an interstellar object. Unlike typical comets, which follow elliptical orbits bound to the Sun, 3 Atlas follows a hyperbolic trajectory, ensuring it will eventually exit the solar system forever. Its direction of approach is another curiosity. The object entered the solar system from a region of the sky roughly 9 degrees from the location of the 1977 WOW signal. The unexplained radio burst once speculated to be of extraterrestrial origin. The alignment may be purely coincidental, but it adds a historical resonance to the event and has fueled public fascination with the object. At this point, attention turns to the various spacecraft capable of observing 3 Atlas from Mars orbit. The European Space Ice Mars Express Orbiter and ExoMars Trace Gas Orbiter were scheduled to capture images and spectra of the object during its closest approach. According to ISSA, the distance between 3I Atlas and Mars on October 3rd was approximately 30 million kilometers, or 2 astronomical units. Later in the year, ESA's Jupiter Icy Moons Explorer, JUICE mission, will also observe 3I Atlas as it nears perihelion and continues outward toward the orbit of Jupiter. Because of JUICE's current orbital geometry, data transmission to Earth will be delayed until early 2026. This delay means that the most detailed observations of 3I Atlas may not be publicly available for several months. Still, these measurements are expected to provide unprecedented insight into the physical and chemical nature of the object. Beyond ISA's efforts, other international missions may contribute. China's Tianwen-1 orbiter, which has been operating around Mars since 2021, carries multiple scientific instruments capable of imaging celestial targets. If Chinese mission planners decide to repoint those instruments toward 3-2 Atlas, the resulting data could be among the highest resolution available. Similarly, the United Arab Emirates' hope,